Welcome to another short and sweet video. This time we're going to do one on one-dimensional motion. We are given a couple of facts: that the acceleration is 4 meters per second squared, the initial velocity is 5 meters per second, the delta t was 14 seconds, and the initial time is 6 seconds. So what can we do with this? Well, delta t is defined as final minus initial. So with that in mind, 14 minus 6 is 8 seconds. Distances we don't know. Velocity final we don't know. The average we don't know. Change in velocity we don't know. So at this point we need to start looking down at what we have here. Do we have any formulas that have things? Well, I got a velocity final, initial velocity, acceleration, and time. So it seems to me this would be a great candidate to put in velocity initial, 5 meters per second, plus 4 meters per second squared, times time, which is 14 seconds. And of course we did this backwards, didn't we? Final minus initial. This should have been at 20 seconds when I rearrange everything around. So that'd be 14 plus 6. But that doesn't really matter. Just wanted to fill in the blanks. So now we need to sit there and say, okay, what do we know? Well, if I got a calculator, which fortunately I have, I can clear this up. 4 times 14 gives me 56 meters per second increase in the original speed. So this gives me 5 meters per second plus 56 meters per second. And you go, because I had a second here and that cancels out with that, and that gives me 61 meters per second. And with that in mind, I can go 61 meters per second. Velocity average, well, I can go through some of these things, but I can find this one here. So I've got final is 61 plus 5 divided by 2 equals 66 over 2 equals 33 meters per second as an average. And with that, can I figure out my change in distance? Yes, I can take this equation and make it into d equals velocity average times t. Velocity average times t is 33 meters per second times the time involved, which is 14. And I go 33 times 14, and I get 462. Now, just for fun, we can also use this one right down here. Distance initial. Well, it doesn't tell me one, so I can assume 0. 0 plus velocity initial, 5. That was meters per second, times change in time, 14 seconds, plus 1/2 4 meters per second squared. Now, easy way to do a lot of this is sometimes run the calculator backwards. That means I'm going to take times time squared, 14 times 14 on the seconds, seconds, boom, boom, boom. And what this is going to get me is 14 squared times 4, cut in half, that's 392 for this part, meters, plus the quantity 5 times 14, and this gives me a total of 462. Now, for those of you who were wondering what was going on in the middle, 5 times 14 is 70, plus 392 is 462 meters. And funny, this one and this one match. So my distance final was 462 meters. And we computed the distance twice. And if you like, for fun, we can even do this one on the back. Velocity final squared equals velocity initial squared plus 2AD. I can rearrange this to say velocity final squared minus velocity initial squared over 2A equals to D. Velocity final was 61. 61 squared minus, I believe it was 5 squared, and this is meters squared, seconds squared when I square those, divided by 2 times 4 meters per second squared. That's going to cancel with that. That's going to cancel with that. This is giving me an answer in meters, which is what I expect. Get rid of that. And now this becomes 61 squared. 61 squared is 3721 minus 5 squared. 5 squared should be 25. Whoops. 5 squared. 25. So 3721 minus 25 is 3696 divided by 8 meters per second squared. And this gives me 462 meters. And once again, we've got the exact same answer now using all 3 versions of the formula. If you didn't follow all that, play it a couple of times and then come ask me questions.